T2.5. The average yearly snowfall in Chillyville is approximately normal, with a mean of 55 inches. If the snowfall in Chillyville exceeds 60 inches in 15% of the years, what is the standard deviation? All right, so this is a very challenging question that's going to require a little bit of everything. We're going to sketch a picture, set up an equation, and use a little bit of algebra. All right, so first let's go ahead and draw our model. Okay. All right, so this is a normal distribution with mean of 55 inches, standard deviation unknown. Okay, well, we can at least label the mean, right, 55. Okay. All right, now we do have another clue, which is the boundary value. So 60 is the boundary value, and 15% of the time that will be exceeded. Okay, so that means that 60 is going to be somewhere to the right, and the area beyond 60, right, because it says exceeded, that's going to be 15%. Let's write it as 0.15. We'll write it as a proportion. Okay. All right, that doesn't get us too far. Okay. It would be great if we somehow knew the standardized value, right? So we know that 60 inches, right, is the boundary value for the top 15%, but what z-score, right, is the boundary value for the top 15%? Okay, so let's redraw our distribution. As a standardized one. Okay. So in a standard distribution, the mean will be 0 and the standard deviation will be 1. So that will be 0, and this is going to be some z-score. All right, let's see if we can figure out the z-score. Okay. Now, if 15% of the area is in the right tail, then that would mean 85% of the area is in the left tail. All right. And now what we can do is we can go to our table here and we can look for the percentile closest to 85%. In fact, I think that's it right there. Okay, 8508. Right. Now if we work backwards, we can see that the z-score is approximately 1.04. Okay. All right, so we can come back to our image here. And let's update it. So the z-score is approximately 1.04. All right, so now we've got a new piece of information. All right, let's set up an equation. Well, the only equation that I know that would apply here is the z-score formula. Right, the z-score is equal to the value minus the mean over the SD. Okay, do we know the z-score? Yes, 1.04. Do we know the boundary value? Yes, it's 60. Do we know the mean? Yes, that's 55. And so there's only one unknown in this equation. Okay. All right, so let's go ahead and substitute the values we know. 104 equals 60 minus 55 over SD. Okay. All right, if we do a little rearranging, right, we could multiply both sides by SD over 1.04. Okay, why do that? Well, 1.04 cancels on the left-hand side, and the SD cancels on the right-hand side. So now what are we left with? The SD is equal to 60 minus 55 divided by 1.04. And of course I closed my calculator, so give me a sec to launch that. Let's see, separate and combine. All right, so we want to calculate fraction 60 minus 55 over 1.04. It's about 4.807. 4.807. Okay, well, looking at the answer choices, I guess we would have to go with A. That is the closest value to what we got. At least the first two digits are correct.